Hey everybody, I hope you're doing well out there, wherever you are in the world. And yeah, we're going to get started very shortly. I'm just organizing a couple things, putting the word out that we're going live. I hope everybody's having a great week. So as I mentioned before, this is something that I'm trying to do on a weekly basis, and it's something that I'm doing mainly to try to push my own development, but also I think it'll be helpful for other people that are trying to learn as well. Well, I hope so. So yeah, everything here as well. Yeah, we're gonna get started today, and so I'm just gonna go ahead and open up my JUCE project, and I'm gonna turn off the air conditioner here because it's getting a little bit cold. One second. Okay, so, um, so let's see. So in some of my past tutorials, I have um, worked with so I have a DJ app game that currently exists that I've been working on for quite a while. If you've been following my live streams for a little while, and um, and so I'd been doing that, and then while I was doing that, I started getting some ideas about workflows and things like that, and that led me to think that it would be great just to experiment and start a new DJ app from scratch, because I think that would be a lot more useful for people that may be watching this, to see how a code base goes from something quite simple to something quite complicated. So, so what I did was I decided to start again and just start working through these concepts, and I'm going to do my absolute best to try to think through these problems rather than just looking through the code base of the other DJ app that I have, where I've already answered all of those questions and people have helped me to answer those questions, and just try to think through those again. And I'm hoping that it will help us think through some some ideas, and also come up with some great code snippets that I think would be useful for the community and for other people that are seeking to learn how to code. So, as I always say, there's a quick disclaimer at the start of this. I'm not a what I would call like an expert audio developer. So I'm still learning, like so many other people out there. And if you have suggested ways to make the workflow better, or to improve the code that you see here, please feel free to chime in on the live chat, and I'm always more than happy to receive your feedback and look to make myself a more effective software developer. So yes, please do not, please take any code you see here with a grain of salt, and don't be afraid to suggest improvements on it. I'm very receptive to feedback. So with that, what I'll do is I can walk you through some things that I've done since the last live stream. So what I'm trying to do is I'm also trying to make sure that the main bulk of the work that I do is live, so people can see as I'm doing it. And but I did a few small little things. So in our last live stream, we were working out this process of like how do we connect a mixer device or a USB device, and each device has its own set of sample rates that it wants to operate at, buffer sizes, things like that. So so what I did was I created this mixer device class, which essentially is a way that I can classify what a mixer is, what the input and output device names are, what sample rate that it's supposed to, what the default sample rate is, what buffer size is, how many input and output channels it has, and things like that. So this is kind of a, like a cookie cutter, so to speak, for what a mixer, the information that a mixer would have. And then from that, I've created a mixer device list, which is simply a vector of mixer devices. And here I have my my personal mixer at the moment, which is this Pioneer DJM S9. So that's the audio name. Then you have the MIDI name. This is the sample rate it's supposed to operate at, the buffer size it expects. These are some MIDI channels and CCs for the audio, for the crossfader of the mixer, and how many input and output channels it has. Then what I did was I created a device scanner. So with a JUCE audio application, you have a device manager. So device manager, I guess it would be helpful if I actually pulled up the JUCE API so everybody can see. By the way, JUCE has been making some various improvements to their website, and this is really awesome. I can actually walk you through this really quick because I think it's really cool. So if you go to juice.com, and you can see down here, they actually have, they've actually got a lot of tutorials, so a lot of really great tutorials. They're very in depth, and they're on loads of things. They've really expanded this, and it looks really good. So now I'm in just the JUCE API, and we're going to look at the audio device manager really quick just to show you what I've done. So when you have a JUCE application, this automatically comes bundled with an audio device manager. So this is what manages the state of what sound card that you're playing in and out of. And what you can do is you can actually give your audio device manager another audio device setup. An audio device setup is something like what I had for the here. So in this mixer device, I've got this method that I've created where I basically say, okay, so I've just plugged in a mixer. If that mixer is on my list, then it will it'll automatically pass the values of all those to these variables, and then I will pass that to my audio device manager, and that will create my new setup which basically takes the audio device manager and it gives it the new buffer size, input and output devices, and so on and so forth. But I still needed a piece of code that was able to look when I actually when I actually connect a device, something that actually goes through and it basically answers the question of, okay, when I connect a device, is this device a device that we have in our device list? And if so, pass it the settings, or else no. So I had to create this little class, which I've called Mixer Device Scanner, and what it does is it's a change listener. So it's listening for changes from the audio device manager. So what happens is you plug in the USB device. Then the device manager says a new USB device has been plugged in. Then it signals to the mixer device scanner, okay, scan and see if this USB device that we've just plugged in is part of our list of devices. If it is, then we want to update the update the settings, the device manager settings, to what our new mixer is. And that's exactly what it does. So we just needed to go through kind of the quote-unquote JUCE way of doing this, where we go through, iterate through all the device types, and then scan the devices that are plugged in. Then we needed to compare that with our device, with compare each device name with the devices that we have listed in our mixer device list. And if the device name is listed, then update the device manager. So that's essentially what I've done there, and I've put that in this little folder, and that all sits there. So then comes the question, okay, how do we actually take a look at settings? So then I've created a what's called a dialog window. So a dialog window is like a second window that it's a JUCE class that will let us create a second window that kind of holds our components, holds UI components, and when we're done with that second window, we can exit out of it, and it doesn't exit out of the entire application. So I will just go to that class now if I can find it. There we go, dialog window. So this is another one that's another class that's helpful, that can be a little bit confusing to actually use. So this is a dialog style window, so it's like a second window that opens up in your application. And what you can do is it contains this struct called launch options, and launch options gives you some options in terms of configuring the actual window itself. So then you can you basically can say if you want it to be resizable. You also have this content method that allows you to essentially take the say what component that you want the dialog window to take control of, and things like that. So let me just run it for you, and I'll show you what we actually have. And we also have, and so this dialog window, then the question becomes, well, how do you actually open the dialog window? And that's where I've created a text button called settings button. And then what I've done here is, in this piece, I've created in Lambda using the button on click method that allows me to just say what I want to happen when I click the button. So we can see that we already created the settings window, this dialog window settings window, as a class member. And then in here, I'm just configuring it with various settings, and then I'll launch it, which means that it opens the second window. So we can see that I wanted to call it settings. I want the component that it takes over to be the audio device selector component, which is just a JUCE class that displays the audio device settings. Say what size I want it to be, and launch it. So when I actually compile this, then what we'll see is something that's quite simple, but quite cool, in my opinion. So just waiting for this to build. By the way, another thing that I should mention is that I'm going to make this project open source, or I already have made this project open source. The link to the repository itself is in the video description, and also I'm going to use this to create some code snippets for our audio audio programmer wiki as well. So, and I've already done that. So if I'll just take you there very briefly and I'll show you. So as you can see, I've been quite busy. So if we go to the audio programmer wiki, there's already some stuff some articles and some useful pieces of code that some people have already shared. So in here, there's a code snippets section, and I've created two of those that are around what I've just shown you just now. One of which is a device scanner. So if you're ever in a situation where you're creating a audio app with JUCE and you say, I need something that that scans my devices and identifies if the device is a device in a list, this is a code snippet that could be useful. Another one is what I just described with you about the dialog window, so second windows. So this is just kind of like a hello world for the dialog window, just a very simple use case. So yeah, so that's essentially what we have on the wiki. But there's some other stuff here as well. So feel free to go through and hopefully. And I know that I will personally be adding more to the content here as we go along. So that's what I'm aiming to do. So that's that. Nitra asks, can we watch these videos in a playlist so I can watch the previous ones? Yes. So what I will do is, after I get done with this live stream, I will actually take this and the previous live streams and I will put those into a list where you can watch the previous ones after that. So I'll do that right after I finish this. So another thing that I intend on doing is creating video tutorials of all of the general things that we're learning through here. So I'll create a video tutorial of the dialog window and of the audio device selector component, things like that. And so it'll be like a cornucopia of tutorials and materials to help everybody else, including myself, with. So I hope you enjoy it. So this is what we have so far, which is just a window, just a blank window. And then when I click on the settings, button, it opens up a second window, and that has my audio device selector component. Okay, so let's just see, so you can see the code alongside what we have. So that's lines 29 through 35. So your inputs and outputs, how many lines it has selected, and so on. So so now what I'll do is I'll plug in my mixer device, and fingers crossed, and it all works properly. It should automatically update the settings to the mixer device. So let me just go and plug that in very quickly. So here I have my USB device, and I'm just going to plug this in. And it should update. Boom, there it is. So as we can see, the only thing that didn't change properly was, or maybe I need to wait for a second, is it looks like the buffer size is still 512 samples, which is curious, but looks like everything else updated correctly, so it works. And then when I unplug it, it should go back to our Thunderbolt. So, oh yeah, interesting. Error when trying to open audio device, couldn't change sample rate. Okay, so that's something I would need to take a look at. And and we can see when I unplug it, it doesn't fall back to a default device, which is interesting as well. But I mean, there are a couple things that we could do there. We could make it where we could make it where when a device is connected or disconnected, that we have defaults that it falls back to. But that's something that we could do a little bit further down the road. But I think that's okay for now. So now today, what we have is we're going to look to create an audio file player. So basically what we want to do is we want to load a file and play it. So let's see what we need to do that. So it's something that I've done a couple times before. There are a couple classes that run in tandem with each other that we need to put together and to get this to work properly. But we'll kind of push through it together and see if we can get this thing going. So that's our objective today, to play a song through the application. So let's go back to our JUCE API here, and so here we go. So here we're back in the API. So one of the first classes, and there was one that was where we had to register the format. So there was like an audio format manager. So yeah, so we have a couple different classes here. So we got an audio format manager. So this is a class that allows us, if I remember correctly, to essentially register our formats so that when we want to play an MP3 file or when we want to play a WAV file, that we have these decoders that are actually able to take a WAV file and actually decode it properly and say, hey, I recognize that, that's a WAV file, and actually be able to play it through our through an audio through our application. So we have that. Then we have this audio format reader that reads samples from an audio stream, and so we have the format manager that registers format. We have format reader that reads samples from a file stream, and then we're going to need a file class. So there's going to be a class that we're going to eventually need to deal with called file, which is a class that we use to actually load a file, and we give it some type of path. What else do we have? So then we have, I believe there's a class called audio source, audio file source, something like that. So let's see here. Memory audio source. An audio source that takes some float audio data as an input. So this looks like a something along the lines of what we might need. So we can see that memory audio source inherits from positionable audio source, where we can set so a type of audio source that can be repositioned. So we can set the next we can set a position of it. We can actually loop it as well, which is pretty cool. So yeah, so the objective for today is just to try to get it to load an actual file and play it. Okay, so first thing that we want to do is we will create a audio format manager. One of the things I can say is that I've worked, like I said before, I've worked with these classes a couple times before, so I know my way a little bit around these classes, even though it's been a little while. So, so I do happen to know that the method that we want is this one called register basic formats. So just as handy method to make it easier to register the formats that come with JUCE. It'll add the WAVE and AIFF and others as well. So we can actually take a look at the class as well, because I think that'll be helpful for what we're doing. So, so let's see. So I'm just going to start off. I'm going to just put this in our main component for now. And then once we have figured out the basics of it, then we can actually move it over to its own class. So I think it's called Audio Format Manager. Let's see if it takes any sort of constructor or anything. So we can see that creates an empty format manager. So we just see that there's one constructor there. So we'll just call that format manager. I'll call it audio format manager, just to make sure that that's clear. And then let's see, where shall we put this? So just figuring out an appropriate place where we can move it a little bit later. I'll just put it here for now. Before we do that, actually, let's just take a look into the class together so we can actually see what some of the things that it does. So we can see that we have this method where we can register a new format and make it the default format. So if we wanted MP3 or WAVE or AIFF if we wanted to register just that one specific format, we could do that. But then there's this handy one called register basic formats. If we wanted to clear the formats, we could do that. If we wanted to get the number of formats that are supported currently, we can do that as well. So pretty handy stuff. And then going down here, we see that we have this method called register basic formats, and it's like what I said before, where it will actually register these formats for us to be able to load it within our app. So we got WAVE, AIFF, FLAC, OG Vorbis, Core Audio. I didn't know that was its own format, but pretty cool. MP3 and Windows Media Audio. So it loads all those formats with this method called register basic formats. So let's go ahead and just do that within our constructor, because we only need to do that once. So audio format manager, register basic formats, and there we go. So now what we need to do is we need to figure out, okay, how do we actually load a file? So maybe if I pull up what I like to do sometimes is I like to just pull up a little text editor here, or just sometimes I actually have like a notepad and I just write it on a notepad. I find that very helpful. So so we're going to need to have something that has a file location, right? So load an audio file from a location. Then we need to be able to, so that's going to go into some type of, memory, right? So these are just things that I'm thinking. I haven't, I don't really know clearly yet what, like exactly how that's going to work. So it'll load into memory. And then the question becomes like, how do we play the file? So there's going to be, maybe there's a, so let's go back to positionable audio source. So we had, what was it? Memory audio source was the one that we were looking at, right? So we have this, so let's take a look. So we have a prepare to play method. We have a get next audio block method where we actually where it would actually play. Then set next read position. Okay, so let's go to, let me go to audio source and just see what that is. The base class for objects that can produce a continuous stream of audio. And we have a whole bunch of different ones that we have here, right? So class has two states, prepared and unprepared. When a source needs to be played, first needs to be put into a prepared state by a caller prepare to play. Then repeated calls will be made to its get next audio block method to process the audio data. Okay, so that's fine. Let's oh, I hate when it does that when my window drops down like that. Okay. We got this audio format reader class. So I'm just trying to remember how this, aha, here we go. I'm starting to refresh my memory now. There's this method called create reader for that searches through the known formats to create a suitable reader for this file. Okay, so maybe we can start off by creating a button that just says load file. So let's write this down, right? So let's go back to our, so now we're going back to our first step, right? Which is load an audio file from a location. So maybe this just means create a button that opens up a file chooser that where we can choose an audio file, right? Something like that. Then V would be when, so you choose the audio file, then we're going to need to call create, so then looks like we create a reader for it. To create a suitable, so that returns an audio format reader pointer. Okay, so let's take a look at that. So if none of the register formats can open the file, so this actually opens the file. It's the caller's responsibility to delete the reader once it's returned. Okay. So then that creates an audio format reader. And then what do we do? So that creates the reader. Then we will read samples from the stream. So the destination channels, number of destination channels, start sample and source, number of channels to read. Okay, so this looks like a way that we can read through and actually, so it reads it, but then how do we actually, here we go. Read, where we give it an audio buffer object, the start sample, the number of samples, use the left channel, that's Boolean, and use the right channel. Okay, cool. So call create reader for, this will return an audio format reader pointer. And then it seems like the next step would be read the file and push through the audio buffer. Yeah. So let's see how far we get off of that. So step one, create a button that opens up a file chooser where we can choose an audio file. Okay. Seems simple enough. So I will create a JUCE text button, load audio button, load, and then that will take a string. I'll just say load. I'll call it load. Then I'm just going to put this here, load audio button, set button text, load. We will add it and make it visible. Load audio button. And then we'll put a position on it here. Set bounds. So we will put this, let's say, I don't know, 10 to the right, 200 down. I mean, this can just go anywhere for now. Let's just make sure that our button actually shows up as we would like. Okay, so now we have this load button. We click on it and it does nothing for now. So I believe there's a class that's actually called file chooser. So let's just take a look at that class. I believe it's called file chooser. Okay, so Oh, cool. File drag and drop target. That could be useful later. So creates a dialog box to choose a file. Okay. So we can say the directory, we can say the file, so we can give it a string of file patterns allowed, and a couple other things. So shows a dialog box to choose a file to open. Okay, so I could do this. I'm gonna take a little bit more of a simplified approach for a moment, just to try to get something going a little bit quicker. And what I'm going to do is I'm just going to try to find. Hopefully, I actually have an audio file on this computer, and I'm just going to try to load it from an absolute path just for now. Let's see, I must have a audio file somewhere here. Let me see if I have. Here we go. So, okay, I found one. So I'm just going to call this Alibi. So this is a song that I created a long time ago. So let me see here. So we have, so let's see. There's this load audio button, so we can create a lambda that says what we want the load audio button to do. And we will give it the scope of the class, and then, okay, so when we click it, we want it to load a file from our chosen location, create a reader for it, and play it, maybe. Okay, so let's see. Sorry, I've got a couple windows open here. Okay, so let's just try to fumble our way through this class and see if we can get something going. So we've got this memory audio source. We've got prepare to play. So memory audio source takes an audio, so it takes an audio buffer as an argument. Copy the memory. Okay. Okay, so just thinking through how I actually do this. Okay, so let's go back a step for a moment. Let's go back here for a moment. Just try to walk ourselves through. So we have this create reader for that returns an audio format reader pointer. Okay, so let's start there. See if I have no idea if this is the right way or not, but let's just see if this is what we want to do. So we'll just call this auto reader equals audio format reader create reader for, and now this is going to take a file object. How does that want to okay, so then we could do JUCE file, and we can make it take an absolute path. Okay, so let's just try that. So we'll create a new JUCE file object in line like this, and then it will take a string of a path. So so one thing that I like, file paths are really easy to mess up. So one way that I do this is I will actually just open my console like this. I will drag this like so, and boom, I have my file path. So I'm just going to copy that. Okay. So now we want to load this file, create a reader for it. So now we want to see, maybe we could just do a check to see if the reader is actually pointing towards a place in memory, or if it's null pointer. So we could say jassert reader is not equal to null pointer. So let's just try that really quick. See if that actually. Let's see if there's actually a any sort of method that lets us know that the file is valid. So we got file exists. Okay, so that feels handy. So we can actually, let's just do this, JUCE file, and we'll just call this music file, and then we will give it all of this good stuff. And then we can just do a jassert music file is valid. Oh, did I not do that right? Oh, it's exists. Sorry, exists. Okay. So we're doing two checks. We're doing two checks here. So if it once we load the audio button, it should do this. If it doesn't actually, if it pauses execution here, then we know that we have done something wrong. So so let's try it. So here we go. Actually, let me just do one other thing as well, just to double make sure. So we could do a debug, a little debug message here, just to let us know that we have indeed clicked on the load audio button. So load button clicked, just to make sure that because if everything goes right before I wrote that, then we actually would see nothing would happen. So it'd just say, just do nothing. So here we go. So it's done something there because audio device manager would like to access files in your desktop folder. So boom, it's done it. So we can see, so something's happened here. Okay, and I know what happened, but let's see. Unfortunately, it doesn't give us any useful information, but I actually know what happened here. So we see that we hit this JAssert false, and it says if you hit this, you've leaked one or more objects of the type specified by the owner class template parameter. Where's the owner class template parameter? Let's see if I do this. Okay, it doesn't, but I will go ahead and give you the correct answer to this question, which is that we have this pointer, this raw pointer that we've created in the reader, and we didn't actually delete it at the end of this, or delete it anywhere. So here, this is the correct thing that we want to do. So we just want to make sure that that actually works. I think the actual probably more correct way, and maybe somebody more experienced in the that's watching might be able to give some guidance, is to actually wrap. There's a way that you can wrap a raw pointer within a unique pointer. But if we do this, so here we go. Once access to the desktop folder, we hit OK. So all that worked properly. So now when I exit out of this, it shouldn't give us that anymore. So see, now we don't get that that bad message anymore. So let's just take a look and see if we can wrap, just for the heck of it, just because we love doing things like this, how to wrap a raw pointer within a unique pointer. Does it make the code unnecessarily more complicated or not? So wrap raw pointer and unique pointer. So it looks like something. So here we go. So some post from not too long ago. So let's see. Okay, so looks like this is pretty easy. Make unique some raw pointer. Okay, so I think we can so we could do something like this. Let's see. So make unique some raw pointer. Okay, so let's maybe call this R, and then we could say auto reader equals stood make unique, and the type is JUCE audio format reader, and then R. And if we do that, then hopefully the compiler won't complain on us. Build failed. Allocating object of abstract class type audio format reader. Okay. So what we're doing is, let's see, what do we want here? Let's think about this for a second. Allocating an object of abstract class type. So it's saying audio format reader is an abstract class. But I'm not seeing any abstract. Oh, read samples. So read samples is a pure virtual method. Okay. But it's not an audio format reader, is it? It's an audio format reader pointer. Let's see if that. Yes, build succeeded. Okay. Did it work though? Load. And we got no complaints. And now we can close out of this. Uh-oh. It's still giving me JAssert false. So it's still leaking. Okay. So I'm missing something. Okay, so let's see. So R is a raw pointer. I've made it unique. I've made it a unique pointer. Okay, I'm going to go with my intuition here and do this. Okay. Okay, so that worked, and then no, still not right. Okay, so let's go back to what it was saying. Just make sure that the raw pointer never gets stored in any containers or member variables that it's passed into. Make sure all copies of the raw pointer die with the call chain in the same thread. In the same thread as the owning unique pointer. Okay. I love how, so let's see. Okay, so let's see what else it says. Unique pointer is a class that wraps a plain pointer to a dynamically allocated object. It owns and manages the object and forward calls and accesses the objects. But when this unique pointer goes out of scope, it properly, yeah, okay, we know that. Okay, let's try something else besides Quora. Wrapping resource handles in smart pointers. Okay, so let's see what this says. Okay. Okay. I like how these, it'd just be nice to have like a, these are so, okay, let's go back to Stack, our good friend Stack Overflow. Too bad I don't have ChatGPT. I could ask GPT. Um, yeah. Should be used, in your case, the correct way should be used as shared pointer constructor. Hmm. Okay, let's go back to stood, make unique. So let's see here. So a wave morpher says there's a bit of periodic noise in the background. I think that's my dog snoring. Okay, so we're just trying to take this raw pointer, wrap it in a unique pointer, but it's still leaking and I can't figure out why. CPP reference, always. Let's do my favorite, Geeks for Geeks. Oh, there's a rhythm of periodic whitish noise, wave morpher says. Ah, yes. Maybe I have my... Let me try this. 1 second. I think it's that maybe I have the sound floor a little bit set a little bit too high. So what about now? Well, okay, so I need that up there. Let's see here. So we could turn the gain down like this. Can you still hear me okay? Or if I turn this down. Okay, what if I do that? Still gotta... How's that? Is that any better? That's definitely not what we want to do. Okay. Okay. I know that probably didn't fix it, but I need to. What I need is I need to get my gate, but the gate that I have is so finicky that it'll take me a while to do it, to get it right. I'd rather just continue on with the live stream. But oh, is that actually better? Okay, fantastic. Okay. So, okay, so we're trying to figure out how to wrap this unique pointer. I'm pretty sure that I actually did this in a different project. Hold on, let me reference my other project here. 1 second. I'm going to. I'll feel very guilty if I don't give the correct answer. So let me do this. Create reader 4. So, no, that's what I do. I do the same thing. Um, oh no, I don't quite do the same thing. It's just declaring a, it's just doing this. So, unique pointer. Oh, I should have just kept it up there. JUCE audio format reader, and then I just called it reader and R. Okay, so now let's try that and see if that actually works. I'll keep my notes. I'll keep my notes handy if I, just in case I. Okay, here we go. Load, access desktop. Okay. Ah, there it is. So that's what it was. So rather than make unique, it's just declaring a new unique pointer. So that, my friends, is how we take a raw pointer and safely wrap it in a unique pointer. Okay, so we've loaded the file into the reader. So now let's go back to our kind of pseudocode. Read the file and push through the audio buffer. Okay, so here we go. So read through the file. Sorry, I got to move this down a little bit so my Zoom is interfering with me. So here we go. So let's get format name, read, destination channels, number of channels, read the samples from the stream, fills a section of the audio buffer from this reader. Okay. Is there like an audio, what would be cool is if there was like an audio file player class or something like that that we could just look at. So let's just look at that. Let's see, player, audio processor player, audio source player, exactly, yes. Wrapper to continuously stream audio from an audio source to an audio I/O device. Okay, so then we got this audio device I/O callback with context. Audio source. So set source, it takes a audio source, and then we can set the gain of it. So let's just look at what this does. Implementation of So we need to pass it. Okay, so currently it's in the reader. We need to get it into the audio source, right? So we were saying that there are these audio source classes that let's go back to that for a second. So we were looking at I think we were looking at memory audio source. So I don't need these audio format We don't need the file class. We don't need the audio. So memory audio source. So it takes a audio buffer object. So does that mean that we need to by providing an audio buffer. Okay, so I think let's take a look at what memory audio source actually does. Okay, so we give it some sort of audio buffer, and then does it automatically initialize it, give it space, and all of those things. So let's just have a look here. Okay, memory audio source. Okay, here we go. So, okay. Okay. So then we go get next audio block. And it expects an audio source channel info reference. Is there a way to like set gain or anything like that? So there's unit tests. I'm just a little bit confused as to how to actually get this thing to actually play audio. Okay. Okay, so that's that class. So let's look at audio source player. Here we go. Okay, set source, so you can set the gain. Okay. So it calls get next audio block. I suppose that we could just apply gain ramp, or just multiply our so let's just do this. So let's go here. Audio format reader source. Okay, maybe we try audio format reader source. Suggestion from Wave Morpher. Okay, so let's go back to here. Audio format reader source. Type of audio source that will read from an audio format reader. Okay, cool. So let's take a look at this one. So we got get next audio block, set new. Okay, so let's just try that one. So it's a type of positionable audio source. And this Oh, so this looks like the right class. Yeah, so let's try that. So we're gonna just try to get it playing, and then we will and then we'll come back and we'll like later on we'll add functionality to it and things like that. Um, so audio format reader source. Okay. So then, does it need to, um, the only thing is that it needs to take, oh no, so I could just give it a null pointer. I could just give it a null pointer for now. Is there like a um, set audio format reader? So it needs a, so does that mean that we need to create an object of an audio format reader object that as a member variable? So Wave Morpher asks, I thought you wanted to play from a file. Yes, that's true. Yeah, so I've created the reader for it. Okay. Okay, I've got a clue as to what I need to do. Um, so we just need a place to store it now, right? So then, so what if we create a audio buffer object, put the data into the audio buffer, and then copied from that audio buffer to our main buffer. Right? So what about that? So let's see. I'm pretty sure my memory is refreshing now. So we go back to, I want audio form, none of these are what I want. So let's go back here. So we want audio format reader again. Okay, this is what we want. Reader.read. It gives it an audio buffer object, start sample, and the destination buffer, number of samples, reader start sample, use, so that seems, fills a section of an audio buffer from this reader. So we don't want this. We want a JUCE audio buffer audio, I'll just call it a temp audio source buffer. So now let's look at the audio buffer class. This creates an empty audio buffer. So then we want to So what do we, so now the question becomes, okay, do we set the size of the buffer here? So would it be something like this? Audio source buffer set size, number of channels. So let's see, is there something where we get how many channels are in the reader? Get channel layout. Returns the number of the channels in the set. So where did I get that from? So get channel layout. Reader get channel layout. Reader get, see, I was hoping that it would be get num samples. So let's see, is there anything like that? Oh no, look. So actually you could just do this. Reader num channels and reader length and samples. So here we go. Num channels, then reader length in samples. Okay. Then reader read, and then the buffer that we want, audio source buffer, start sample and destination buffer 0, num samples, reader length and samples, reader start sample 0, use reader left channel true, use reader right channel true. So, oh, what did we miss here? So something's not quite right. Okay, so let's go back to this. So reader length and samples. So int64. So that's an int64. That's 0. That's fine. These two are bowls. That's fine. Start sample and destination buffer is fine. So this needs to be a pointer to the buffer. So this actually just needs to be like that, the memory location of the buffer. Okay, so let's try that. And okay, so implicit. So now we just got int64 to int. So we could just do this. We could static cast int. So we're just gonna cast this to an int. Since we're doing that twice to clean up the code, we will do auto num samples equals all of this, just to make sure we're not just keeping everything clean. So num samples, and then this can be num samples. Okay, so that should get rid of that. Then let's just make sure that that everything is good to go. So we could say num samples is greater than 0. And reader num channels is greater than 0. So we just want to make sure that we're actually getting valid samples and numbers of channels there. Okay, so let's see how to, yep. Let's see. I'd love to know from people what the, I suppose it's, got this, just creating the narrative here. So select a music file, we're making sure the music file exists. We're creating a reader for that music file. We've wrapped it in a unique pointer, made sure that the reader is not equal to a null pointer. We've created the number of samples, just a temporary variable for a number of samples. We set the size of the audio source buffer, make sure that it's actually greater than 0, and that the number of channels is greater than 0. So just making sure that we indeed have a valid audio file in there, and then we read the samples into the audio source buffer. So we're just going to compile that, make sure that actually compiles. Okay, then we're just going to hit load, make sure it all actually loads, close out of it, closes out fine, no leaking. So that seems like that is working fine. Okay, now the question becomes, how do we actually play the file into the buffer now? So we got 2 audio buffers. We have an audio source buffer, and what we need to do is we need to take the audio source buffer and I guess at sample at buffer size chunks, take the audio source buffer and like go down the line of the audio source buffer and copy it through to play it through the main buffer. Sounds right, I think. So, okay, so now let's see here. Let's go to the audio buffer class, see what we have. So there must be like a copy 2 or something like that. So we got apply, so copy from. Okay, so we got copy from. Copy samples from one buffer from another buffer to this one. Okay. So is there the thing that I'm thinking about is sample rate. What are you going to do? What are you going to do about sample rate? If the sample rate of the sound card is different than the sample rate of the file. You're going to need to make a calculation there. But maybe we don't worry about that for now. Maybe what we do is, for now, what I'm going to do is just to make sure that these are actually, like, I'm going to apply a gain to this to make it just really low. So it would be audio source buffer dot apply gain. To which channel? Okay, so I'm just doing this just to make sure that if the audio data actually is junk, then we don't want it to harm us. So we could just do for int I equals 0, I is less than num samples I plus plus, or actually that's not what I want. Int channel equals 0. I'll just make it ch rather than channel. Ch is less than reader. Actually, we want to make it audio source buffer num channels. Channel plus plus. Then we're just going to apply a gain to all of this. So this will be ch starts, nope, not char, just ch. And then, oh, this is a private member. That's no bueno. Get num channels. Get num channels. There we go. So num samples will be num samples float gain. So I'll just put this as 0.2 of what it normally would be. Yeah, so we'll do that. So that just applies apply temp gain to track. Protect our ears. Okay, so now we're going to need some type of sorry, just checking things here. So now we're going to need some sort of process method or something that, so we need to consider sample rate. What sample rate our sound card is at versus what sample rate our track is. Okay, we'll come back to that later. We'll just assume those are the same, and we need to do like a copy from. So let's just make a process. Well, like I said, we'll move this to a separate class and everything later on, but just something to get us started. Main component, process audio. And then I will just make this a private method here for now. Void process audio. It's going to need to take, it's actually going to need to take this, because we're going to need to pipe that in to actually copy that into our to copy. We need the buffer that we need to copy everything to. So so this is audio source channel info reference. We need to get a buffer from that. So here we go. That's the pointer to our buffer. So we could say auto buffer equals buffer to fill buffer, right? Buffer. Okay, so that's a pointer to our buffer. Just gonna compile this, make sure it's all compiling all right. Cool, build succeeded. So now we need we're going to need our buffer size. All right. Can we get that from? I don't know if we can actually get that from our audio buffer. So we've got get num samples. Do we have a so we got num samples. So it would be something like copy audio source buffer to main buffer. So wouldn't it be copy buffer size number of samples of audio source buffer to main buffer? So it'll be something like buffer to fill copy from when there. Oh, it's because it's a pointer. Copy from or buffer copy from. Okay, so let's see here. Okay, so we see that destination channel, destination samples, source channel. So this is going to now need to be wrapped in a for loop for int ch equals 0. Ch is less than buffer get num channels. CH++. And then, another thing is that this is kind of assuming that the number of channels from our source buffer is equal to the same as what our destination buffer is. So we will need to put an assertion of buffer get num channels is equal to audio source buffer get num channels. So we're just going to assume that for now. So let's see, your destination channel will be CH, start sample, destination start sample. Okay, so, we'll come back to start sample. We will, the source to copy from is audio source buffer. The source channel will be CH. Start sample, we will figure out. So the sort and the number of samples would be buffer get num samples. So now we just need to figure out the start sample and the source start sample. So destination start sample would be 0, right? Because we want to start at the beginning of the buffer that we're trying to fill. The source start sample will be the source start sample will need some sort of we'll need some sort of counter. So some sort of position. So let's say, let me just create something like int read position. And then so this will be read position. So read position starts at 0. Then it would be read position plus buffer get num samples. Right? Okay, so WaveMorpher says get next read position from positionable audio source. Except I didn't use a positionable audio source. I actually just used a audio buffer, right? Yeah, no, I just used an audio buffer, and I'm actually just reading through taking the read position and adding buffer get num samples, and then that should just play through the song, right? I'm hoping. Okay, so here, so let's see. What I could do is we could call process audio on the buffer to fill. I feel like I'm doing something not quite right, but I'm going to try it. Okay, we need one other thing. This is going to try to, if we do this right away, this is going to try to start reading from that buffer that doesn't have anything just yet. So we need something else here. So we need some sort of bool is file loaded. We'll just say that's false for now. And then in here, once it's done its thing, we can say is file loaded is equal to true. And then here we could say if is, or actually I'll call it file is loaded. That feels a little bit. So we'll do it like that. File is loaded. And then in here, I will rename this file is loaded. Okay. So what I'm going to do is I'm going to make my headphones very quiet, and I advise you do the same because I'm going to try to actually do this, and I have no idea if it's going to work or not. So so everybody turn your headphones down, and let's see if this actually works. So if this actually works, then we should hear something through the file, through the speakers once I've loaded the file. So I'm going to just look at the settings. Okay, so the settings are fine. Sample rate is 48,000. Okay, so let's see if this actually works. Okay, so once I hit OK, if everything works properly, we should hear music. Ha! It works! Ha ha! How about that? Actually works. It's playing at a different sample rate than the song, but that's okay. That's okay. It actually works. I can't believe that we actually got it working. Awesome. Okay, so now so that actually worked. Can't believe it. I'm actually surprised with myself. So, okay, so now, wow, really cool. So now we can have like stop, right? So let's expand it. Let's expand off of this a little bit. Main component, stop audio. And then that would, then it comes to a question of, does stopping bring it back to the beginning again, or does it keep it at the same place? So like, let's say that we want it to So let's see. Let's see how we can do this logic. So if we wanted to stop audio, then we would just, maybe we just have a Boolean of play and a Boolean and like maybe it's an enum play state playing or stopped. Maybe that's, so now we get to something like this, like there's a question from Wavemorpher. Do you think Traction Engine handles buffering and streaming many files from disk in parallel more than just JUCE? I mean, I imagine so. I imagine that Traction would be very optimized for that. I mean, the reason so there are two reasons why I haven't used Traction Engine for this process. One is because eventually I want to control the position of the file with control vinyl. And I don't know if Traction Engine is flexible enough, if the engine is flexible enough to allow me to do that. And the other reason was just more of like an educational reasons for myself more than anything, which is just thinking through how to actually do this. So Wavemorpher asks, why not? It would just be a number. Well, yeah, but it's got to interpolate. It's not just giving a read position. It's actually, you're going to have to, if you have control vinyl, you have to interpolate every callback from the position that you were at to the position you were at in the last callback to the position you are at currently. Like if you're scratching. Yeah. It would be cool. Actually, when you say that, it actually would be kind of cool as an experiment, just to be like, okay, let's pick up Traction Engine and let's see if we can do the same thing with Traction Engine. How long would it take us? What would the advantages be and things like that? It would be really cool, actually. It makes you think. So, okay, so let's create a enum. I think I actually did a file player with Traction Engine, and it was actually really easy, if I remember. So we're going to do an enum class play state where we do stopped. Playing. Traction Engine tutorials would be my biggest wish. I think that I think it'd be cool, actually. Traction Engine tutorials. Yes, I did do some Traction Engine tutorials. It'd be cool to do some, actually. Okay. Like maybe these live stream sessions can be more like explorations, something like this. I mean, this is pretty cool. Felt pretty cool. So, okay, so yeah, maybe Traction Engine tutorials would be pretty cool. I like it. Okay, so let's do a couple more simple things. Let's create a play button and a stop button. So We will create a play button and a stop button as well. Jas in the house. What's up, Jas? Yeah, we need, so Wave Morpher was saying about the podcast. We need to get that podcast going again. And my son, Alex, I don't know what he's been doing, but for about a year now, he's supposed to have been resurrecting the the old podcast episode, and we have loads of new great ones as well. Um, great talks from people, and we need to get those back online again. Okay, so let's do this play and stop audio button. So got load audio button. We got play audio button, set button text, play, stop audio button, stop, and then we can just add and make visible, play audio button, add and make visible stop button, and then we just set some positions here. Play audio button, set downs. So we will do this 10, so this will be, let's say 250, 200, 100, and stop audio button, set downs, be 10, 10. That can't be 250, that will need to be 350, which means I'm just checking my size. So my size is 600. So, okay, so let me make these a little bit smaller. So I'm gonna make these 50, 100 by 50. Actually, what I'll do is I will do something like this. Auto button width equals 50. Auto button height equals 100. Actually, I just call these. Should I just call them? Is it too like non-descriptive if I just call them W and H? I mean, I feel like that's just pretty obvious what it is, but I don't know if anybody feels that that's big. Please let me know. Okay, so this could be 250 now. So let's see, so height, this is meant to be 100. This is meant to be 50. So we got 10, got 200, we'll do 260, or yeah, 260, then 320. Okay. Now we just need to do a little bit of logic. So as you can see, this is going to need to be reorganized and kind of put into different classes and stuff, but play, audio button, on click. So we just want to say what happens when we hit the play button. So if, so we need to create a play state. This is what everybody loves, is controlling state. Play state, play state. Stopped. All right, so this is just a state that we've created using a enum class that will describe whether our play state is in play state, stopped, or playing. So if play state is equal to play state stopped, play state is equals play state played. Else else nothing. Yeah, I think that's fine. Use which instead looks way cooler. Which? Switch. Ah, switch. Ah, yes. Yeah, but then let me think. Yeah, we'll use a switch in process audio, I think, right? Or maybe switch. I think if it's just two states, then maybe I'm not sure that we need to use a switch just yet. Let's see how it goes. I like the idea though. If if play state is equal to play state playing, maybe it just needs to be this, right? Do I need to even, and then the logic lives play state stopped, right? Then process audio is if file is loaded and play state is equal to play state playing. I suppose that there could be thread thread issues. So let's see. So the text button, so the text button is changing the play state. So do I need to make this atomic? I don't think so, because one thread, which is I'm assuming the message thread, is controlling the play state, which would be the buttons. The buttons are controlling the play state. But the audio block is only reading what the play state is. It's not trying to change it. So it's not two threads trying to change. Is that right? So I'm not going to get into any sort of thread trouble. I don't think. So, okay. So let's try to compile this, see if this actually loads. Okay. So there we got our settings. We got our load, play, and stop. So when we hit, so it should just continue when, so if we stop and then we play again, it should just continue playing from the point where it stopped from. Okay, so the file is loaded. Now I can hit play. Okay, and I hit stop and it stops. And now when I hit play, it should probably play from the position that it was at. Boom, there it is. That works. Pretty cool. That actually works. Fantastic. Okay, so now I'm just starting to think of how to make this into a class. So I'm just looking, we have this one. So one thing that I've been working really hard on is just separating UI and data. So I think this would be a cool exercise to try out, just to see how we would do that in this scenario. So in this scenario, we have an audio button that is controlling what's happening to some data, right? And let's start factoring that into a class together. Okay, so let's pull up and then we'll call it a day. Yeah. So I'm going to create a new. So let's see. Shall we start with the data? I feel like we should start with the data first. So new CPP and header file. So in our source, I'm going to create a new folder. I'm going to call this we could call it audio deck. Player, yeah, audio player. That feels like a suitable name. And then I'm going to separate this into. I'm going to create one that is UI, and then I'm going to go back to audio player and create another one that is data. And then in the data one, I'm going to create a header in CPP, and we will call this uh, audio player data. Audio source data, audio player data. I think audio player data sounds good. I'm just trying to future-proof this, so I'm just thinking of how to handle this. So I'm just going to call it audio player data. I can come back to it later. Now there's this weird thing where it doesn't create the folder the way that I would like it to. So I just remove the references to this. And what I do is I will reveal in Finder. I'll go back to where I was. Oh, actually, let me create the other files actually as well. I will call this audio player UI. And I will put this in audio player. And then what I'm going to do is I'm going to get rid of the references to these and just drag audio player in. Use audio, so Jess says use audio name for data and control for UI. Yeah, that feels... Use audio name. So instead of data, it says audio, and then UI is control. Is that what you're saying? Just trying to. Once you reply to that, I'll. Okay. So rather than data, this is called audio. But it's more than audio, though. It's data, though. It's more than, yeah. I'm going to keep it with data and UI, I think. I'm not sure what the official kind of way that that's supposed, if there's like a good guidance on that or not, but I feel like data and UI feels like intuitive because it's actually more than data. It's more than audio. Yeah, like because it's like it's logic for it's actually logic for loading files and things like that. So yeah, I'm saying that because everything that I do, including what I have a mixer device and all this should actually be under data as well, I think. That's what I've been trying to do anyway. Okay, so anyways, so I'm going to take the audio format manager that goes into audio player data. So this is going to be class audio player data. It doesn't inherit from anything. And we will have public and private. And then we need to bring in good old JUCE header. Like so. And then what else do we have here? So then we're going to have this audio source buffer read position, file is loaded, and play state should all be data, I believe. That's all data. Then let's go back here. So we got this enum class play state. For now, I'm just going to put this in here, like so. I imagine that I'll probably move that eventually. Then our load, play, and stop button will all go to UI. So here we have that. And then we have this process audio method. So that is a your data thing, right? So that will be a public method. Then, so that's cleaned up everything here. And then in and then this, so now we're just going to go down method by method and thing by thing and kind of figure out what the heck we're doing here because we just got a bunch of bread. So audio player data, so we're going to need some type of constructor. And this will be audio player data, and it's going to register basic formats. Then what's next? So going back here. So all of these UI things are going to go in UI, but there's a problem because the UI does not know about the data it controls. Okay, so all this stuff is good, but it's looking like, so there's one other thing as well. So where's that audio? Did I put audio buffer in audio data? Yep, so that's fine. So now what we want is where are we? So we're in audio player data. Okay, so we have all this stuff. So we've taken care of all that. So now we need all of this. So we have this load button, this load audio button that before was doing all of this stuff, which was loading audio. So feels like it makes sense to me to have a method, a public method called void. Maybe this could be bool, right? Because we want to know if it loaded. We'll make it void for now, but maybe we come back and make it bool, right? So void load load file, maybe load file, we'll call it load file for now. So void audio player data load file. And then we just put all of that business in there. So that's all just data stuff, right? Nothing of this has, nothing in here has anything to do with UI, okay? Actually, if I remember correctly, I think reader read actually returns a bool, if I remember correctly. So if we go back to audio format reader and read, yes, see, so that returns a bool. So that will be handy just to ensure that so let's see here. So I can actually say file is loaded, or file loaded successfully. File is loaded equals that. This can be like an apply gain function. So what I was doing is I was applying a gain. So I can make that a separate, I think we will make that a separate method. So I'm thinking about a couple different things at the moment. So void set gain, float new gain, and then in here does it have access to our buffer, audio source buffer? Oh, no, it's fine. New gain. It's just I haven't put it in the class yet, so. So we got set gain, new gain. So here we go. Void set gain. So all this. So now that should be fine. Num samples. So we want auto num samples is equal to audio source buffer get num samples. So we're going to make this return so let's see. So do I want to say return file? So it feels like I want to say just return. This will be a bool. I will change this to a bool. Was the file load successful? Then, okay, so we got that, we got set gain. Let's go back here to, okay, so we have this play state. So we have, okay, so I feel like this needs to be separated out into another class. Like play state should probably be off on its own, like its own separate thing. then the audio player itself is in its own class. So maybe what we do is we create another small, maybe it's just a header file. So what I'm going to do actually is I'm just going to do one little thing that's bothering me a little bit while I'm doing this. So mixer device, just going to put this in to make everything the same. I'm going to make a folder called data just to emphasize that all of this stuff is data stuff, not UI stuff. I'm going to create another folder called state. Then I'm going to create a header file. I'm going to call this audio. So what shall we call this? Audio player state. Okay. Then I'm going to drag that into here. Why didn't it drag the file though in there with it? That was weird. What's going on here? So let's try that again. So we got state. So okay, so let's delete these. Let's delete this, just the references, and now we've got source, we've got audio player with data and UI. Now we got mixer device. And we got state. Great. So now I feel like we're ready to move on. So, okay, so now in audio player state, we can just have this enum class. So I'm going to change this to audio player state. Audio player state. There we go. Then we have our audio player data. So now what controls, now the question becomes, where do we control the state from? Okay, so let's go back to the UI. So what needs to know about what? That becomes the question here. So what's controlling, so the state is data, right? So let's see. So place state, I wish I could get a more experienced person to give their advice on this. So let's go back to the audio player. The audio player should just be this on its own, right? It's just the audio. It's just an audio player. That's all it knows about is playing audio. So this should not be here. Shouldn't have anything to do with state or anything like that. So that is being controlled from another place. Now the question becomes, okay, does the state live in the UI? Yeah, because the UI needs to know. Well, it definitely needs to control what's happening in data, right? Yeah, I almost feel like it should. So let's think about this. So the UI is just controlling things that are happening in the data, right? But it doesn't actually, so it's just executing orders, but without the UI, the data still resides and it's still doing what it's doing. Okay, so that means so what does that mean? Okay. So that seems to mean that the state of whether it's playing or stopped should be known whether or not the UI, if you took the UI off of it, it still should know what's happening in the application. Right? That's what I think. You know, like the UI is just like attached to the data. So, and my good friend Marvatronics says bingo, right? So, okay, with that being said, then we just have some controls that are happening. So I need to route in. So it feels like the main component should hold the state of the application itself, whether something is playing or stopped. So I will put that in for now, like that. So, so we will include this here. Include, so let's see, we got state audio player state. And now we've got the play state. I'm going to call it's complaining because this needs to be audio player state. Audio player state. Okay, so then now the UI needs to be able to control what is happening in the data of the UI player. So we need this to include let's see, so this would be data. Nope. // data / audio player data. So now it's just pulling the strings for what's happening in audio player data. So all of this should now, so now we need a audio player data object. Um, audio player data, audio player data. And then all of this should now be audio player data load file. Then now the tricky part becomes, how does play button control the play state of something that lives? So maybe the play audio button and stop audio button become public members of the audio player. So, okay, so, or so the big question here is, where does this live? Audio player state. That actually it needs to know. Okay, so this is just, maybe each player has its own player state. So now I'm going back on what I was saying before, which is that, so an audio player can have a playing state or a stopped state. So now I need to, okay, so I'm going to go back on what I did before, which is to put this back here. So let's see, shall I do it here? And then this no longer has to know about that, because you can have multiple players are going to have multiple player state. Each player should control its own state. So I'm going to make this private, actually. And then I'm going to take this. I'm going to make this private. So I'm just going to change this back to play state again, because we know it's in the audio. Play state. Play state stopped. Then we're going to need a void get play state. Make that const. Return return play state. Oh, what am I doing? this needs to be what am I doing? Play needs to be with a capital P. Okay. I'm going back to I'm starting to go back to a conclusion that because in order to be able to set the play state, it's going to need to know what the heck play state is. So it would be something like this. So once again, it goes back to it needing to live in audio player state again. Okay, we're getting there now. Audio player state, audio play state. Stop. This needs to know about sorry, I missed. So include /play audio audio player state. Sorry, state audio player state. Okay, we're getting there. Cannot initialize return type event with const audio player state. Oh, so this is, first of all, this is audio player, right? Okay. Then we're going to need to do void set play state. Audio player state. New state. Then play state equals new state. Okay. And then this needs to be now included in UI. So it knows what, I mean, when I say audio player state, so now we will say audio player data set play state. Okay. Oh, it's audio player state. Audio. Okay. Okay. Okay, okay, okay. So now that's that. Then we need to include um, audio player, um, let's see, UI, audio player. This is the thing that I'm not. Okay, so let's see how well my architecture has gone. Um, so audio player, UI, audio player. Um, okay, just seeing what the settings button, all of that will need to move to its own class as well. So audio player, what did I call this? I called this just audio player. We just need to add and make it visible. Okay. Then okay, so this needs to go in. Okay, let's see. Okay, let's go back and put the buttons where they need to be first. Okay, there's. So we can just put this over here, audio player UI, and resized. So we just take all of this, take this here. Put that here. Okay, we're getting there. So I've made let's see, so I've declared my audio player data object in the UI. That does not feel, so it almost feels like I need, so I've got the UI, I've got the data, I almost feel like there needs to be a place where I define what I want to happen between the UI and the data. Because I feel like okay, these are buttons. Hmm. Just thinking. Just thinking. You have these buttons. You have these things that you want that these actions that you want to be taken when the buttons are clicked. That's fine. My problem is well, my problem is a method that I haven't actually moved from my main component, which is this process audio. So now we have this process audio method that's here, and that feels like that needs to reside here, right? But yeah, this is what is a little bit confusing to me about the main component, because the main component holds both UI and data logic, and that's a little bit confusing to me, because the way that I feel is like this. So let's just get everything into the right place first. So we got load file, process audio. Okay, so this is, let's just get everything screened out first. Audio player data. Okay, I'm thinking something now. I'm thinking that the audio player UI is designed to control the audio player data, right? So what if I made this a reference? And then I passed it in the constructor. So something like this, audio player data NP. And then now, so let's do the same sort of thing here. Audio player data P, then audio player data is now P. Okay, so that means that now I need to declare, so let's start separating this out. So this is UI, right? This is data. And we include audio player data. audio player data. And now I have audio player data, player data 1, so let's see, audio player data 1, audio player UI 1, and now in here, hold on, this should be 150. Then in here, I say audio player UI, and I pass in audio player data 1. So now the UI is a controller for audio player data 1. And then now here I can control the state. So let's see. So here I could say, let's just create a bool. Well, I've been on here for a while. Bool file is loaded equals false. Oh, yeah, that would actually make it cleaner. So Refactoring says you could use brace initialization to just to make it clear. That I think makes it clearer than list initialization. So I could do like this. Yeah, I agree. So, and I will just make a comment here that player UI is controlling data. Okay. So then we can create a Boolean. File is loaded. And we'll just do this to false for now. File is loaded is equal to audio player data 1 load file. So and prepare to play, we try to load the file. Actually, we'll just do it in the constructor because we just want it to. Thank you for all your help, Marvin. Marvin's off to sleep. Yeah, I need to get going soon as well. But we're gonna persevere through this first beforehand. Player UI1 set bounds, then 0, 0, get width, get height. Then I'll put this over top of this. So this is just quick and dirty. So now we just need So now what's controlling the play state? So so now we need a file is loaded and audio player data 1 get play state is equal to play state playing. Sorry. Audio player state playing. Then this should be audio player data 1 dot process audio. Okay, I think we've got it. Okay, so here's this. I'm going to hit load. And now I'm going to hit play. Should play. Boom, it works. So there you go. So it was a little bit of an ordeal to get the data to separate it from the UI, but I think that's good now, because what we have is that if, let's say, we wanted this audio player in another app, now it's just taking this, and we can actually just take this, move this to another app, and without the UI, and it's completely independent. You can put your own UI on it if you want, with its own set of controls. So yeah, if you have suggestions on ways that could be managed better, I would love to hear them. But I feel like that's pretty solid. That was pretty solid work. So we created the player, and yeah, we created the player, and we created the functionality, but then we needed to separate everything out, so we moved it into its own independent classes. I hope that you found that educational. I'm going to push this code. Like I said, if you're interested in the code itself, it's in I have it on my repository. So so please feel free to comment on it, to look at it, to clone it, and I hope you enjoy it. I'm just going to push this to the repo now, and then so yeah, I'll show you how to do that as well, if you're, just in case you're so I'm going to change directory to the JUCE DJ app, and I'm going to do git add dot, so just adding everything, git commit -m, created basic audio file player, and yeah, I think that's enough to say. We could do git, so now we can do git push -u origin main, and there it is. So like I said, the repository is in the GitHub repo. I hope you enjoy it. Please feel free to leave comments, suggestions, ways that this can improve, and I hope you enjoyed this as much as I did. Thank you very much, and we will see you next time.